For this lesson, we're going to start the journey of taking a closer look at the graphs of rational functions. This time we're going to especially focus on the asymptotes. So let's take a look at our objective, which is to be able to graph rational functions. When we look at two standard types of graphs that you'll see a lot of different graphs. Today I'll give you a couple examples that look different than this, but these two types of standard graphs, when you look at this, what you have is your vertical asymptote is right here at h. So we're just going to list our vertical asymptote as x equals h. Our domain then is that x cannot equal h. So notice that the asymptote itself is something that we don't actually get to in the domain. It gets close to it. Notice that this graph is going to hug it closer and closer as we go toward h. We're going to go down to negative infinity. This one's also going to hug it on this side of the asymptote. Same thing with this. They both are coming close and hugging the x equals h. That means that the domain is all reals except x cannot equal h. So that's how we'll be able to list it. Now, if you're doing it in interval notation, that would be negative infinity to h, and then from h to infinity. And this would not include the h in the middle. Now, the horizontal asymptote here is listed at k, if you notice. And so we would say that our horizontal asymptote is y equals k. And that idea of looking at k, notice that if we were to talk about the range, there's many different ways to list the range, but if we actually talked about the range, we'd say that y could not equal k because it doesn't ever get there. But more specifically, I'd like to talk about end behavior because the horizontal asymptote gives us information about the end behavior. What we want to recognize with this is that when we have x going to negative infinity here, as x goes to negative infinity, notice that this y value is getting close to the k. So y is getting close to k. And so that's our end behavior. The same thing happens with going to positive infinity. As x goes to positive infinity, y is going to get close to k. Now this time from the top side, but it doesn't actually get to k, but end behavior is what are you going to? And this is getting infinitely close to k on the top side here, on the bottom side here. Notice that even though they're both on the top, you have the exact same end behavior. As x goes to negative infinity, y is going to go to k here from the top side, and as x goes to positive infinity, the y is going to go to k also from the top side and get infinitely close to it. So that's our end behavior. So the horizontal asymptote is going to give us the end behavior of the graph. That's a key idea. The end behavior comes from the asymptotes. In this case, it's going to be the horizontal asymptote. All right. There will be other types of problems where we'll see asymptotes that are not always just horizontal. Sometimes they'll be in shape of, for instance, a parabola. All right, let's talk about these asymptotes a little more closely. So we're going to talk about this horizontal asymptote. We need a little more information about how to figure out what this horizontal asymptote is. And so we're going to set up another chart here. And the idea is you've got to compare the degrees of the numerator and denominator. So notice here you have the degree that matches. So this is the case where the numerator degree equals the denominator degree. So put that equal sign in. This one, notice that the numerator degree is smaller than the denominator degree. So I'm going to put a less than symbol here. And then lastly, when the numerator degree is greater than the denominator degree, I'm going to call that a bonus for right now. That's going to be a challenge, okay? So we're going to wait for this for later, just to kind of work through what that looks like, okay? Now, but for this one, when we have the numerator degree equal to the denominator degree, the horizontal asymptote is what we're talking about, is going to be y equals, and it's going to be the leading coefficient of the numerator over the leading coefficient of the denominator. So for this example here, notice that the degrees are the same, so my horizontal asymptote is going to be that y equals 7 over 5, just the leading two coefficients. Doesn't matter what these two numbers are, it's going to define it by being the leading coefficients. Now, if the numerator degree is less than the denominator degree, this means that this is going to go, as it goes to infinity, this is going to go to infinity a lot faster, because notice it's got a square on that x value. So what this happens here is our horizontal asymptote will just be at y equals 0. It's going to get, this fractions get smaller and smaller and smaller as we go to negative infinity, or to positive infinity, and get closer and closer to 0 as we go to negative infinity. All right, let's take a look at some examples of this. Okay, we're going to state the asymptotes, sketch the graph, and state the end behavior for this. The key idea for this is make sure as we sketch that we get the end behavior of it through the horizontal asymptote in most of these cases, and also be very precise about the vertical asymptotes. So the asymptotes are important as we sketch the graph, which means we don't go for a lot of points off of the table. We go instead making sure that we get the shape and we get the precise asymptotes for this. So for 9 over x squared minus 9, notice that the degree on the top is less than the degree on the bottom. So this means my horizontal asymptote is going to be y equals 0. So this will just be a dotted line here as on this problem, okay? So for that one. All right, now, we want to get the vertical asymptotes. We've got to factor the bottom to see where that equals 0. Remember, the denominator is, we want to make sure that from the denominator, we get our horizontal asymptotes. And so when we do that, let's go back up here. Notice that that's from the vertical asymptotes are from the denominator. So let's put up here from the factored denominator. That will help us find what that vertical asymptotes are going to be. So for my vertical asymptote here, what will make this equal to 0? So that would be at x equals 3 and x equals negative 3. Those are the two that would make that equal to 0. So I'm going to draw a graph here, and I'm going to go out to negative 3, draw an asymptote, and we go out to 3 and draw a vertical asymptote. Okay? Now, once you do that, you have to look at your graphing calculator. When you draw this with a graphing calculator, it will help you see the shape of it. And so once you graph it on your calculator, what you're going to see is that the graph is going to be a hyperbola-like curve over here, and also over here when you graph it there. And then in the middle here is what's a little bit different. It actually kind of looks like a parabola going down here, and it goes through at -1 here. So we've got a graph that looks a little different than we're used to, but we've established our asymptotes, both our vertical and horizontal. Then we looked at the graphing calculator to get the shape of it so that we could draw the sketch of it. Now we've got asymptotes, sketch the graph. Let's state the end behavior. Notice as x goes to negative infinity, the y is going to go to 0. It's getting close to the x-axis. And as x goes to positive infinity, the y is still going to get close to that axis and get close to 0. So that's our end behavior. Notice that this middle section here doesn't affect end behavior at all because it's what's happening as we go to the infinities. All right, let's take a look at this second example. Notice that on this one, my degrees are the same. They both are degree 2. So our rule is if they're degree 2, our horizontal asymptote is just going to be the leading coefficients. So it's going to equal 2 over 1, which is just 2. So I'm going to go up to 2 here and draw a dotted line for my horizontal asymptote. Right now I'm going to go down to the denominator here, and I'm going to look at what the factored form of it is. Okay, I'm going to leave the numerator as is. You don't have to worry about factoring. It does factor, but I don't need to worry about it. I'm just going to go x for now. We are going to, as we go to part 2, look at what happens when you factor these and how that impacts the numerator as well. But for now, I'm just interested in the denominator. So the vertical asymptote is going to be x equals 1 and x equals negative 1. Because that's what makes the denominator equal 0. So let's do negative 1 here, vertical asymptote, and also at 1. Okay, for the graph. Now let's go ahead and draw the graph. You got to look at your graphing calculator to get the shape. So the shape will point out to me as I draw the graph. I'm going to have the curve over here going like that. It's now below the horizontal asymptote, but it's over here. And then this part, the middle part, is going to be up here, looking like that for my for the middle part of my graph. Now we want to do our end behavior. So as x goes to negative infinity, we're getting close to this 2 on the y-axis from below, but it's still getting close to it. So y goes to 2, and as x goes to positive infinity, the y is going to 2, but from the bottom. Okay, so I've got my graph. So what we want to do is to establish our asymptotes. We want to make sure that we look at the denominator factors. Where do they equal 0 in order to get those vertical asymptotes? And then the horizontal, we use our rules. If the degrees are the same, we look at the leading coefficients of them. So 2 over 1 would be for this one. But if the degree on the top is smaller than the degree on the bottom, then we just have a horizontal asymptote at the x-axis, which is y equals 0. Look at your graphing calculator then to get the shape of the graph. And then once you've drawn it, you can then state your end behavior based on your asymptotes.